Hi, we are glad to introduce our KDD paper that proposed the student parallelism for efficient GPU inference of BERT. We investigate how different factors affect the inference efficiency on GPUs. The top left figure shows the secretion layers linearly increase the latency, while the top right one shows that different model Ys can keep the same efficiency. The bottom left figure shows it needs a large enough batch size to utilize GPU's parallel computation capability. And in bottom right one, sequence length can significantly affect the efficiency because of its O(n) squared complexity. Previous efficient inference works pay more attention on weak edge devices instead of the parallel GPUs. Therefore, they tend to reduce the overall model size other than the secretion layer number. Additionally, they have to pay extra costs of idle waiting and extra paddings to form large enough data patches for data parallelism. To solve these problems, we proposed the novel student parallelism. It distills the deep models into a parallel group of flat student models instead of the single student. By virtual stacking of multiple students, it can trade more parallel students for fewer secretion layers, and adaptive student pooling can reduce the number with minimal accurate loss to improve the throughput for workload burst. Finally, we exploit the student parallelism to reduce the data parallelism and its extra costs. Experiments show that student parallelism is in the top left corner, which is the ideal region. In particular, our student parallelism can reduce the model depth to only 2 layers. Even compared to the 4-layer tiny BERT, it has higher scores and can save more than half latency. Thank you for your interest in our work. Welcome to meet us on the site of KDD 25.